Hello world, and welcome to the introductory lecture for CIO 320, Chemical Engineering Design. Chemical engineering design is, well, all about the design of processes and operations that are used to convert stuff into other stuff. I'm Ryan Merkel, and I will be providing you with all the information and guidance you will need to complete this final stretch of your third year studies. Koketso has offered her time up to assist you when I'm not available, so please feel free to send her your queries. Jonathan Reinders will be submitting his dissertation soon towards a master's degree, and so he won't be available anymore to assist us. So we will be finding a suitable replacement soon for him. So I'll give you some more information on that when I know more. We will commence with our online lectures, which occur Mondays through to Thursdays, with our tutorial sessions being scheduled for Thursdays. But please feel free to treat these times more fluidly according to your own busy schedules, especially for this semester. But at the same time, also try to keep up with the work. And speaking of schedules, be sure to work hard at this module specifically, as it tends to be a tough one. Simply because it's more applied in nature and there are more practical bits that could be more difficult than what you are used to based on previous modules. It is a 16 credit module, and this just relates to the fact that you are expected to spend at least 160 nominal hours working through the study themes. So overall, try to aim for approximately 1.1 hours per day to work through the work and to be on the safe side. As a design module, we will use several compulsory and recommended textbooks that you will also likely want to be using for your design projects next year with Professor Mike Heidenreich. This module is an amalgamation of two previous modules, which were 8 credits each, called Heat Transfer and Piping System Design, or CPS. As design-based modules, it was decided to merge these into one complete chemical engineering design module. Thus, the first textbook we will be making good use of is by Schengel and Gajar, called Heat and Mass Transfer Fundamentals and Applications. A recommended textbook to make use of, especially for next year as well, is a more practical textbook. So the textbook's name, we refer to it as Coulson and Richardson's Chemical Engineering Design. It's the 5th edition and it's volume 6. There are several other volumes that you can have a look at too, as they apply to various topics of chemical engineering, such as biochemical engineering, etc., and serve a similar purpose, but a more in-depth purpose to what Perry's Chemical Engineer's Handbook relates to. And speaking of Perry's, it too is an essential part of obtaining various information that you will be required to make use of in this module. So, for example, if you see words or concepts come up from time to time that you aren't specifically familiar with yet, such as piping schedules, superficial gas velocities, liquid hourly space velocity. The onus is on the students to find out, using whatever means possible, what these terms or words mean. Oftentimes we go through a lot of definitions, and you will more and more see things or concepts or entities that you won't necessarily be familiar with, but that there's also no time to really go over in lectures. So this is to help you better prepare for your final year and for when us lecturers are no longer around to help and guide you along your endless road of learning. Another helpful book that we'll be making good use of is the Piping System Design textbook. It was written in-house, and there's a PDF copy which is available to you on ClickUp on the module page. We will be using this consistently and continuously And you may find it useful when you are a young working engineer one day, which was the case for me and my peers back in industry. Now, assessments for this module will comprise of shorter semester type tests, which comprise 42% towards the year mark. The semester tests will be broken up into smaller bits. So we will be having a more continuous assessment through the semester rather than just two big chunks of semester tests during the engineering test weeks. These will also be accompanied by typical class tests that contribute to 28% towards the year mark. The class tests are more used for formative learning, and so they will typically provide additional attempts so that if you make mistakes, you can use the class tests to learn from your mistakes and better prepare for the semester tests, which will summarize and integrate some of the work that we've learned so far. Now, because it's a design module, there is a practical assignment that will be given to you. This needs to be completed, and a sub minimum of 40% for the assignment is required in order to promote, and will contribute 30% towards the final mark. The assignment description will be provided to you by the end of this week, and the year mark will then be a contribution of 80% towards the final mark, and the exam will contribute just 20% towards the final mark. Heat transfer will be presented concurrently with piping system design. This is to help and facilitate you getting to grips with the assignment and completing all the different aspects of the assignment in due course. And heat transfer will include an introduction. You are already familiar with the fundamentals of heat transfer. So in the beginning, it will be quite easy. We will follow this with conduction, with some convection, but we will obviously be learning about the applications of these concepts, and this will be specifically for heat exchange equipment design, such as shell and tube heat exchangers, double pipe heat exchangers, plate and frame heat exchangers, etc. And lastly, we will deal with concepts that surround boiling and cooling, because a lot of unit operations in chemical engineering plants require the boiling of liquids and the cooling down of them. For piping system design, we will go over the physical properties and the fluid dynamics, which you are already familiar with, and also the pipe flow concepts before getting into the practicalities of actually designing piping systems. The design equations are typically based on the mechanical energy balance. It looks reminiscent of Bernoulli's equation almost, but there are some bits that we add to it. We will also have a look at compressible flows, Newtonian flow, multi-phase flows, as well as designing piping systems, and end off with how we control flow with control valves, and also how do we initiate flow using fluid movers such as pumps and turbines, etc. To help you get through all the work, I've also uploaded some supplementary slides for your perusal. These are typically based on the textbook that we will also be making use of, and also a previous addition to it. And so these can supplement the online lectures, and also if you don't have easy access to a textbook. The online lectures such as this one will be posted on a weekly basis for you. And then also please note to make use of the other channels that are available to you, such as Slack, and also make use of each other when going about your learning endeavors for this module. And I hope to see you guys soon. Cheerio!